Hello students, welcome to the video lectures of speech and natural language processing. We are in our fifth unit and this is our second topic. So today we are going to discuss about phonetic analysis. So we have seen phonetics, role of phonetics in our speech and natural language processing, and we have covered about the phonetics part in our previous videos as well. So today we'll see the phonetic analysis part. So phonetic analysis is the study and processing of the sounds of human speech, focusing on their physical, acoustic, and articulatory properties. It involves converting written text or spoken audio, that is the speaker who speaks, into phonetic representations, which are essential for tasks like speech recognition, synthesis, and language modeling. I'll just repeat again. Phonetic analysis is the study and processing of the sounds of human speech, focusing on their physical, acoustic, and articulatory properties. It involves converting written text or spoken audio into phonetic transcriptions, phonetic representations, which are essential for speech recognition, synthesis, and language modeling. Okay, so what are the key components of phonetic analysis? So first one, you see, we call it as phonemes. So phoneme is the smallest unit of sound in a language that can differentiate the meaning. So examples given are in English, alphabets B and P. In bat and pat are distinct phonemes. So for example, let us say alphabet P and we consider pat. So the initial sound in pat and versus bat. Okay, you can observe that phoneme. Or if we consider alphabet K, let us say for example, so the initial sound in cat, cat, and let us say not, K and OT not. So the initial sound in cat versus not is also an example which tells you about the phoneme. And if we consider the vowel part in cat and cot is another best example. So let us say suppose cat and cot cot. Okay. So the vowel sound in cat versus the vowel sound in cot can be very well understood. So that is phoneme. So that is the smallest unit of sound in a language that can differentiate meaning. Next is phones. So the actual speech sounds produced by the human vocal tract regardless of their role in distinguishing meaning. For example, the T sound in top and stop is articulated slightly differently. That is, you can see the aspirated T and the normal T. That is your top and stop, which contains the alphabet T. Suppose let us say let us understand with another example like if you want to say alphabet P. So okay, for example, let us say pat, pat. So which has a voiceless bilabial stop sound. Okay, bilabial is when your both lips touch together. Okay, that is what bilabial sound is. So if you consider this, the actual speech sound produced by the human vocal tract, regardless of their role in distinguishing the meaning, is phones. So if you consider P as example, so the voiceless bilabial stop sound in pat can be the best example. If you consider the alphabet B, a voiced bilabial stop sound will be occurring in the alphabet called in the word called bat. Okay, if you say bat, bat, you can observe the B alphabet, how it's being pronounced. So it's a voiced bilabial stop sound. And you can also say, take another example as kite, K-I-T, kite, where a voiceless velar stop with aspiration is found in this kite. Okay. And next is allophones, variations of a phoneme that do not change the meaning of a word. I'll repeat again, variations of a phoneme that do not change the meaning of a word is allophones. So example, the P in spin, unaspirated, and pin is aspirated are allophones in English. We have seen the top and stop example in phones, right? That you can now relate with allophones as well, because if you take the alphabet T in when you say a word called top, so when you say top, that is called aspirated T, and when you say stop, so this is unaspirated T. So both the words you can understand. So just try to say top and stop. You'll see. So top is an aspirated T, stop is an unaspirated T. Likewise, if you also consider some other examples as well to understand allophones, let us say light and dark. And the particular word, what you have to observe in this particular light and dark is, uh, sorry, not light and dark. I mean to say the variation of the sound in variation of the sounds, that is light and dark in lip and ball. Okay, so when you say lip, 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 and ball, ball, so you can see the difference. The L particularly, so lip, lip, and ball, ball. So in lip you see the light L, whereas in ball ball you see the dark L. Okay, that is another allophone example. And if you want to see the example with another word, differentiate this cat and father, where the vowel sound in cat, have some slightly different vowel sound in father. Okay, particularly the alphabet A I am talking about. CAT, 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 and FATH father. Okay, you can observe the variation that is found in the alphabet A. And next is International Phonetic Alphabet, that we call IPA. So standardized system of symbols representing phonemes across languages, where the English word cat is transcribed as in this way. That is about IPA. So next, phonetic analysis in NLP. So phonetic analysis is used to bridge the gap between written and spoken languages. It involves, first is phonetic transcription. So what is phonetic transcription? It's converting the text into its phonetic form using symbols like IPA. IPA is International Phonetic Alphabet. Just now we have seen. IPA or custom phonetic dictionaries. So example given here, HELLO, hello, which is represented in phonetic form. So this is phonetic transcription. So basically phonetic transcription, whenever it is happened, we'll know the exact pronunciation of that particular word without any difficulty. So this is about phonetic transcription, that is converting the text into its phonetic form using symbols like IPA or custom phonetic dictionaries. IPA is your International Phonetic Alphabet, and the example here you can see how hello is converted transcribed into a phonetic form. Second is articulatory analysis, understanding how much speech sounds are produced by the vocal organs. As we have seen about the articulatory organs in our previous unit, where we discussed the role of various articulatory organs in human speech sound production. Whereas whenever a speaker, gives a speech or talks something, the involvement of various organs have been understood in our previous videos about the glottis, epiglottis, alveolar ridge, tongue, teeth, etc., etc. So understanding how speech sounds are produced by the vocal organs is your articulatory analysis. So example, the sound K is a voiceless velar stop produced by blocking airflow at the back of the mouth. So when you trying to say this particular word K, so you observe this phenomena of blocking the airflow at the back of the mouth. Next is acoustic analysis, analyzing the physical properties of speech sounds. Examples are frequency and amplitude. That is acoustic analysis, analyzing the physical properties of speech sounds. Example, the A in cat has a low frequency than I in beat. So beat, cat, okay. You can observe the difference in the frequencies. Next is applications of phonetic analysis. So these are various applications of phonetic analysis. So first is speech synthesis, so which converts written text into spoken by spoken output by mapping graphemes to phonemes and synthesizing the speech sounds. I'll just repeat again. Speech synthesis for the phonetic analysis has some applications, out of which the first one here mentioned is your speech synthesis, which converts the written text into spoken output by mapping the graphemes to phonemes and synthesizing the speech sounds. So example is 12, 25, 2024. Okay. So you can see how it is converted. December 25th, 2024. So this particular grapheme is nothing but it's the smallest unit of written language, okay, which represents the phoneme, as I told you earlier. So it can be a letter or some combination of letters sometimes, or a symbol, whichever is used in writing. Okay, this is simply replicates the written representation of the sounds in speech. For example is 12/25, 2024. That is December 25th, 2024. So second is speech recognition, the application of phonetic analysis part. Second one is speech recognition. So converts spoken audio into text by recognizing phonemes and mapping them to corresponding words. Example, recognizing hello from its phoneme sequence is hello. Okay, this is your phonetic transcription. That is about speech recognition. I'll just repeat again. Converts spoken audio into text by recognizing phonemes and mapping them to corresponding words. Okay. Example, recognizing the hello from its phoneme sequence. So next application is phonetic search and matching. Matching spoken queries to text or audio using phonetic similarities. That is phonetic search and matching. Matching the spoken queries to text or audio using phonetic similarities. Example, searching for Catherine also retrieves Catherine. So you understood the similarities that exist between two when are pronounced similar. Next, language learning tools helps learners understand and produce accurate speech sounds. Next is dialect and accent analysis. Identifies variations in pronunciation between different dialects or accents. Example, the word water pronounced as water, this is American, and water is British. So you can see the phonetic transcription of the word water, which is given here when pronounced in two different languages, two different things. That is, this is American way of pronouncing, this is British way of pronouncing the same word called water. Next, we have some phonetic analysis techniques. So that is first one, grapheme to phoneme. We say G2P, okay, G2P conversion. So what is grapheme? So grapheme, already I told you, it's the smallest unit of written language that represents a sound, and that sound is a phoneme. Clear? And this grapheme can be a letter or combination of letters, or sometimes it's a symbol which is used in writing. Clear? For example, let us say C alphabet in the example cat, where it represents K sound, right? Cat, when we say cat, C-A-T, cat. So the particular alphabet C, which is present in this cat, have K sound. And let us say SH in shoe also represents yes sounds, okay? And EE in C represents the I sound, C, okay? So in such a way, the grapheme can be a single letter like A or a combination of the letters, like we have seen in shoe, CH, or some other kind of examples, some other kind of words, sorry. Okay, so let us see this G2P conversion now. Grapheme to phoneme conversion, which converts written text into phonetic transcriptions using rules or machine learning models. For example, you can see this cat is given as input, and now you can see the output. Next is phoneme recognition. So phoneme recognition is, it detects phonemes in spoken audio using acoustic models and feature extractions. So what are phonemes? Already told you about the phonemes part. Yeah. Do you remember what is a phoneme? The smallest unit of sound in a language, which tries to distinguish words from one another. Okay. Then acoustic feature extractions. So extracts key features like pitch, formats, and energy from speech audio for phonetic analysis. Next, phonetic similarity algorithms is the fourth technique. Algorithms like SoundX or Metaphone are used for comparing and clustering words on based on phonetic similarity. Understood? So this is one more technique for phonetic analysis. Okay, algorithms like SoundX or Metaphone, which are used for comparing and clustering words which are based on phonetic similarity. So, for example, if you consider SoundX algorithm, so basically SoundX algorithm is a phonetic algorithm which it tries to encode the words based on how they sound, so rather than how they are spelled. Okay? So basically, it is primarily used for indexing names in a way which sound similar sounding names. Okay. Next. And one more point in this SoundX algorithm or phonetic similarity algorithm is this particular SoundX or similar algorithm will help in searching for the names which sounds alike but are different, but are written differently. Okay, but are written differently. That's the reason I told where the words where it tries to encode the words based on how they sound rather they are spelled. Next, challenges in phonetic analysis. First one is variability in pronunciation. And yes, differences in pronunciation across dialects, accents, and individual speakers. Example is the tomato, which has American accent and British accent. So you can see the differences in the phonetics written for this particular word called tomato. Next is co-articulation. Speech sounds influence each other in connected speech, leading to variations. Example, the T in cat sounds different from the T in butter. Okay, this is co-articulation. Next is ambiguity in phonemes to text mapping. Some words with identical phonemes have different spellings. So example, TU, okay, this is your phonetic transcription, which can correspond to 2, TWO2, TO2, or TWO2, okay. So if you observe, these three looks very similar or pronounced very, very similar, which any end user can understand only based on the context, but not any other thing. So that is the ambiguity here, phoneme to text mapping, TWO2, TO2, or 2, TOO2. Next, noise in audio is another challenge. So background noise or distortion can make phoneme recognition challenging. So examples of phonetic analysis. Yes, you can see the word to phoneme conversion. So if the input is given as speech, you can see the phonetic transcription. Next, phoneme recognition from audio is this. Next is accent variation. For a particular word called dance, American English and British English, you can see the variation that can be observed in the phonetic analysis. Dance and dance. Okay. Phonetic similarity search. Search query can be Smith, 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 but the matches can be SMYTH or SMITHE, which are having a similar sound or pronunciation for the searched query Smith. That is about phonetic analysis, students. Thank you.